if we look at the global scenario, the future of automotive technology, there are four major imperatives. First and foremost is safety, the second is sustainability, third is efficiency, and the fourth one is environment. Now, on electric mobility, two of these factors are the ones which have pushed EV mobility to a large extent. However, we have to be mindful of the remaining two as well, that is the safety and efficiency. When it comes to utilization of electric energy into moving something, we already have lost a lot of efficiency in the powertrain, in every energy transformation. So we have to catch up with that when it comes to actual energy balance. So from that point of view, I think we as designers have to be mindful of the fact that it's not just energy is free for us to be utilized in whatever way we want. So with that in mind, if we look at any clean city options that globally are being considered, there are on the left side of the slide, you will see various types of fuels. The most common ones are oil, natural gas, coal, and biomass. First four of these fuels are typically directly used by IC vehicles. In the middle part, you will see some kind of obstacles in the form of brick walls. So the top one, petrol and diesel, has got more time because these are well-established fuels. And the basic hindrance is the drilling and refining technology and also the cost involved in this before it gets utilized by the ICE engines. If we look at natural gas, coal, and biomass, there are different obstacles, and in each energy sector, these obstacles are being overcome so that usable fuel is available. Synthetic fuels coming from coal or biomass are, the promising fields when it comes to clean city options. Nevertheless, last two, if we look at nuclear fuel and hydro, solar, and geothermal energy. In fact, for that matter, all these fuels can also be used for generation of electricity and finally also generation of hydrogen, which is of interest to us today. So electricity generation to its utilization in EV has got several obstacles. And these obstacles in the form of energy, electrical storage, infrastructure development, and also CO2 reduction technology utilization when it comes to power generation. So all that put together, what makes more efficient power generation solutions and utilization solutions. So on electricity as well as hydrogen, which is the current topic of interest, most important ones are the storage, infrastructure development, as well as CO2 reduction technology during its production. With that in mind, it's also interesting to see that step-by-step electrification has been introduced on vehicles. First step was on diesel and gasoline. Small introduction of start-stop or belt-started alternators, which is the first block. And on the top, you will see in red color the vehicle cost increase, and the green is the CO2 reduction that is coming out of it. So gradually, one can see that any small technology that was introduced by way of bringing in any electrical controls on vehicles did result into better CO2 control. Moving further to 12 volt or 42 volt micro hybrids gave CO2 reduction of 23%. It had that potential. Then again 42 volts, 120 volt mild hybrid concept gave another potential of 34%, and so on and so forth. If you look at a fuel cell hybrid vehicle or hydrogen vehicle uh, configuration, the vehicle cost increases by say 30%. This I'm talking about bill of materials. This is not the vehicle cost at the hands of customer. So about 30% increase in the vehicle cost gives a reduction, CO2 reduction of 56%. So that much is the potential of electrification to the fullest extent on vehicles. It's also interesting to see some predictions that were made way back in 2010. There, on the screen, you can see four different companies have predicted. The first one predicted that by 2020, about 3 million EVs will be put into market, which will be about 3% of the global vehicle volumes. The PwC report said 1.5 million, and Frost and Sullivan said 4.5 million or so. If you look at the year 2020 data, actually speaking, 3% of the total vehicle population is EV globally. I'm talking about global. That is equivalent to about 3 million sales. And as we stand 2020, we have a global fleet of about 10.5 million, which is very close to one of the predictions that you can see on the screen. Likewise, why I'm showing this is this was based on certain policies adopted by various countries, and they have moved towards it. If we look at what Indian situation is, it's quite different, and we will see how it is. There's another prediction which has been, pushing electrification, which is the oil price, fuel price. If we look at this trend, global prices of fuel, this is something which was one of the factors which pushed electrification to a large extent. And however, there is a complete drop in the fuel prices. At least for now, it's about 45 US dollars per gallon or so. So sorry, per liter or so. That's the only factor which has gone wrong, as predicted earlier. Another interesting study, and all of you as vehicle designers would know this, the cost of lithium battery. And looking at the last 10 years data, starting with high figures of 1160 kind of dollars per kilowatt hour. That was the high price that existed 10 years ago. Gradually, about 20-25% reduction was possible due to advancement in technology. The break-even is expected to be about $100 per kilowatt hour if the battery price comes. Then the IC vehicles will have a break-even with the EVs. That's what is expected. And we are not very far off from there. In another 2 to 3 years, I think we will be reaching that globally, I'm talking. Also, it's interesting to see various governments, how they have encouraged adoption of EVs. There are obviously the consumer on his own doesn't demand electric vehicle. So it's always seen that the governments push through various policies and incentives. Those could be in the form of tax exemptions or public and commercial EV fleet subsidies, or providing home charging stations, R&D or manufacturing incentives, and so on and so forth. On the screen, you will see various countries who are pushing electrification to a large extent, what they have done. So USA has put in loans, there are stimulus funds. France has put incentives in parking, free parking and charging network, and so on and so forth. So when a country like India also looked at these countries, we have to be mindful of our own situation. India is a different market. It's not a simple market as many other countries. So we will see what we have in India, the situation. But before that, this is a populated figure which indicates a very surprisingly high number of vehicle options or the choices that were put in by the manufacturers to the consumers. That you can see on the lower side there is a clustering, and on the upper side there is a clustering. On the x-axis is basically the power and the range available for the vehicle. So there are large number of vehicles which are in lower range capacity and large number happening in higher range capacity also. So the consumer has a choice. Uh, it's interesting to get back to India and see where do we stand. The question is, are we shifting pollution source from the urban to power plant? And I have a detailed slide on that. Infrastructure for support, are we ready? Is EV affordable? There is an initial cost, there is a life cycle cost, and there is a need to have a special promotional price. Then comes most important subject of acceptability of the user. Does the consumer requirement get translated into making these vehicles? And adaptability and availability and such typical solutions. There are, on the left side of the balance, you will see that there are drivers which will push the electrification. On the right side, there are challenges which will pull back the balance. On the driver's side, you will see that all these are true from the government side. That is, government initiatives, rise in fuel costs, or low operating and maintenance costs, and things like that. The challenges are more or less on the technology side. So this is where actually we have to figure in. And your program of next coming days, I think would focus on how to overcome these challenges on such as inefficient battery or pricing or manufacturability and so on and so forth. I showed you globally what is the availability of the vehicle models. This is how we see Indian market. There are models available, but they are just handful. If you look at the way they were introduced, 2001 was the year in which the first EV was introduced. It took them 20 years to establish themselves into the market because of the low acceptability of EVs in the country. On the top side of the graph, you will see the passenger vehicles, and they are hardly handful. So the point which I would like to make is the consumer doesn't seem to be having a choice, because the models that you see are high end. They are otherwise put with a lot of safety margin and things like that. Therefore, additionally, there is a cost premium attached with EVs as well. However, on the lower side, if you see that the buses that are being manufactured in the country, they are the ones which become extremely, costly, and therefore their procurement is becoming a hurdle for the corporations and public authority. On the other side, this graph or this slide indicates high population of, on the top you will see two-wheeler models, on the bottom you will see large number of three-wheeler models. There are in three-wheelers also there are goods vehicles and there are passenger vehicles. So I think the point to be noted is the country doesn't need too much fancy passenger cars. We need mobility solutions. So we should therefore focus on two-wheeler, three-wheeler, and the public transport vehicles, which is our focus area. I would like to highlight here what are the peculiarities of every sector. The goods transportation that happens in the country, 70% of the goods are transported on roads, and that makes it extremely, potential target segment. However, the road network is rather peculiar. Our road infrastructure primarily covers cities, urban areas, semi-urban areas, and rural. So there's a huge network where small packets or even the large intercity, large goods transportation happens. The operations are mixed and the duty cycles are also quite different. I'm talking here about the vehicle duty cycles. So if the vehicle leaves from a point A and reaches point B, uh, there are no opportunities for in between charging. So goods transportation, therefore, is a very, very difficult proposition to be converted into electrification. So here in this case, typically the hydrogen or LNG type of vehicles would be preferred, where large range, say at least 200 or 300 kilometers is available for the trucks. Um, Now, I also heard in the previous presentation, he was talking about the possibility of air mobility sector, that is the cargo drones. And using electrified cargo drones is a very high potential. And I have a slide on that. Goods transportation also is peculiarly, linked with requirement for accessing the remote areas. And having the electrification network there is a big challenge. Now, coming to air mobility sector, that is the drones, as in simple words they are called. On the left side, you will see the advantages that go with it. Most of these drones, I was a part of a review panel while selecting certain technology, high-tech projects for future mobility. And I was very particularly happy to know that there are a large number of projects coming in this area. People are working on electric drones to a large extent, and they can carry the payloads of up to say 50 kg or so. And even the distances can be about 100 kilometers or 200 kilometers, which gives easy access in challenging areas. They can handle emergency supplies, and much is talked about reaching the COVID vaccine to remote places through drones. There's no need for dedicated infrastructure except for the fact that it needs charging ports and delivery ports. And then, of course, energy utilization is quite efficient. It could be point to point, and obviously, it has its own advantages. On the other side, there's a complete lack of regulatory framework on drones. The Ministry of Civil Aviation is working uh, right now on regulating this sector. I was a part of, making regulations through SAE, Society for Automotive Engineers. We are finding this a very, very big hurdle to overcome, primarily because the drones are also, need to be addressed for safety and surveillance threats, and therefore regulating this sector is very, very difficult. Um, Another difficulty is limitation on storage conditions because the batteries that go on it um, have a limitation because of the flight schedules and things like that. They can't store the cargo for longer time. So these are some of the practical difficulties, and that's a complete new area for us to work on development. Um, if we look at now the two-wheeler industry, two-wheelers are essentially small duty cycle vehicles, usually point to point or maybe stoppage in between housewife takes the children to school, drops them, goes to shopping and comes back and goes for office, etc. So a small duty cycle. So during the day, typically 30 to maximum 40 kilometers is the running. That's what makes it very attractive. You don't need too much of big battery, and I'm sure one of your sessions will be on two-wheeler specifically. So these are the highlight points when it comes to designing two-wheelers EVs. Highly cost sensitive. Any incremental cost is very, very highly sensitive market. It's typically used for personalized mobility, and therefore uh, its captive use makes it quite attractive. Wide demographic uses from the small villages all the way into crowded cities, we find two-wheelers. There is a need for home charging, and obviously many of the homes do not have the infrastructure. Therefore, we have seen in test cases where people just take out the batteries, they take it inside the house and they use it for home charging. So that's the way typically two-wheelers are being utilized. Coming to three-wheelers, they have a very different duty cycle for goods and passenger vehicles. Passenger vehicles have typically short distance commuting, then there are stops, change of passengers, and therefore there's a large dependency on public charging facility. The three-wheelers also need fast charging. They cannot afford to lose their passenger. So therefore, during the day, they do not have any opportunity for stopping in between for a long charging cycle. They also have long duty hours. They work in 2 to 3 shift operations. So that means the vehicle is just not available for any type of recharging. That's the reason why it gave rise to the requirement of swappable batteries. So I have a slide on that as well. Then operational cost is a major concern, major consideration, and dependency on credit schemes is another, deciding factors. If the differential cost of electric vehicle goes up, then the credits or the loan facilities are not available for these consumers. Now coming to passenger cars, relatively a simple sector. Range per charge is a concern. Any purchaser will always talk about it. In earlier two sectors which I talked about, range is not at all a concern. The cost of acquisition is a concern. Comfort and safety features are very paramount in this sector. Somebody who is spending 20 lakhs of rupees would demand higher safety, higher comfort. So, possibility of commercial use, that is, the vehicle can also be used as a taxi. In which case, there is a demand on having a bigger boot space. That is a big challenge because once you put batteries inside the vehicles, it uses up in many cases the space which is otherwise available for spare wheels or whatever it is. So that's a big design constraint. There are various charging options that passenger cars demand, either home charging or public charging, highway charging, as well as AC and DC charging. That is a fast and slow speed charging. So this sector is the one which has driven maximum innovations when it comes to integrated power electronics, integrating vehicle to grid connectivity, integrating the data utilization and such. So this is a sector to be watchful of. However, as I mentioned earlier, the volumes don't come from passenger cars. Now, another interesting sector is the buses. Here, there is a cost parity. And as I mentioned earlier, the cost is almost 1.5 times, and therefore becomes extremely unviable when it comes to managing the normal fleets. It has a discontinuous duty cycle. So there are start-stop operations. There is a time where the bus goes into depots. There are variable loads. Not all buses are all the time fully loaded. The buses run on city or intercity operations. They also can go on rural roads. There is a big concern here of the safety of high power handling. And from this point of view, it has got huge options of trying out various charging infrastructure options. There are successfully tried out in India also, we have tried it out, pantograph type of charging or depot charging, battery swapping, and fast and slow charging. That is, the overnight charging can be slow charging. So this is again a fertile ground for the developers to try various technologies or various types of batteries, various types of charging options, and power electronics, of course. Uh, I would now move to the technology development side. If we look at how the technologies got to be developed and their focus areas, one area is the structures, the second is basically ergonomics, the third is comfort, and the fourth one was specific electrification related. How did this happen actually? Because the vehicle manufacturers always look at availability of the technology elsewhere outside of the automotive world. And the enablers there were electronic development, a fast penetration of power electronics, very fast development of alternate materials, in ITS tools availability, large scale integration of network connectivity, and also the tools available for the developers through CAE and simulation mode. On the top, you will also see how the information got to be connected to data, to the intelligence, to the smartness, and to the knowledge that goes onto the vehicles. This is the backdrop in which the intelligent vehicles got to be developed. And since electric vehicles are the ones which have a large, you know, potential for all these factors, they were the first choices for
Madam, your voice is not audible. You are not audible, madam.
Can you hear me now?
Ah, now you are audible.
Okay. So the point is I was making is electric vehicles are the classic candidates to be used as autonomous vehicles. That's because of the high level of information, data, intelligence, smartness, and then of course the knowledge that is available and integrated on board. And how actually this happened in India. Um, if we look at the priority areas that were identified under the National Electric Mobility Mission Plan, um, this was the scheme, as many of you would know, was introduced in the year 2013. Um, this was basically the scheme looked at the cost of the conventional vehicles vis-a-vis the cost of the electric vehicles. As compared to ICE vehicles, 70% of the bill of materials for an electric vehicle is unique and specific to EVs. Say, for example, 10% of the cost of the components goes into making electric brake assist, steering, etc., etc. Battery pack is about 40%. Then electric drivetrain is about 20%. And similar to our IC related small portion, which goes on body construction, etc., is 25%. So, looking at this bill of materials, it was decided that a priority will be based on the cost involved. That is, the battery cell was given priority one, battery management was given second priority, power electronics was priority three, then electric motor priority four, and transmission systems was priority five. And I have seen in last 7-8 years the development actually has resulted into these large number of components being indigenized, being developed in the country, and that is where actually the whole success of large scale electrification will come. As I mentioned earlier, connected, autonomous, shared, and electric vehicles is the future, and electrification is therefore the largest boon for the case penetration in the country. This is an interesting concept that you would kind of like to know. I mentioned about the green or the generation of power. These are the two figures which are the most recent data from the Ministry of Power. It indicates electrification in cities. Typically is say 373,000 megawatts generation. If we look at it, majority is 62% is coming from the total thermal power. 12% is hydro, 2% is nuclear, and remaining 24% is renewable energy sources. Out of these 62% thermal, the right side graph indicates, or the pie chart indicates, that it comes from four sources: coal, lignite, gas, and diesel. Coal is the maximum. Say about 70-80% of the total thermal is coming from coal. So that's a big challenge. And that's the reason why my first question was, are we shifting the source of pollution from the vehicles to the power systems? So this picture must change so that we can get benefits of green energy utilization. And that's another example I would like to highlight here of the technology development that is focusing on electrification. Usually the conventional vehicles are the ones which are used for removing the powertrain and putting the electric powertrain. Here is a complete breakdown of this. I'm taking sound as an example. Likewise, there are several other vehicle performances that get affected when the powertrain changes. So if we look at the sound that is generated by exhaust system, fuel systems, transmission, on the left side is a conventional vehicle. Then power, thermal systems, cooling systems, and intake. These are the components of ICE. On the right, you will see the electrified vehicle. There is a battery, there are power electronics, there is a electric motor or a gearbox, and there is a cooling system. So from where does the sound come? Most of the sound producing components are missing out of it, except for the fact that motor makes a very different type of noise, which is characteristics of EVs, which is quite different than the normal ICE vehicles. So there is a noise footprint which is required for the users, for designers and things like that. So it becomes fairly complicated to generate a noise signature from something which is inherently quiet or a different technology altogether. This is a very big engineering challenge that we have to overcome. EVs are very silent, EVs are very quiet, but EVs are therefore very susceptible to making accidents. We are used to working in noisy vehicles. So this is one difference the designers have to keep in mind, bear it in mind for synthesizing the noise that is required on roads. There is a vital role of artificial intelligence and deep learning that goes on to designing EVs. It's quite interesting how a vehicle to vehicle interface or vehicle to road infrastructure interface happens. Um, there is a requirement of driver in loop behavioral pattern recognition. EVs have a potential to do so. All the controls that are simplified, they are basically running the motor into predefined characteristics. So the interface becomes really very simple, and therefore driver in loop behavioral pattern can be predicted very clearly for EVs, much better than IC. There's a image processing and pattern recognition, which is outside of the powertrain. It has nothing to do with electrification because this intelligence is related to vision and other image that is outside of the vehicle. So there also, it doesn't make any difference for vehicle designers. Then command and control decision matrix and deep learning are relatively simpler for EVs. And that's the reason the electrified vehicles became the most favorite ones for autonomous driving. I would here like to also highlight that as we move towards better and efficient vehicles, we need to be mindful that we are adding weight in designing EVs. That means we are adding more weight to carry more weight, which is not efficient. That's the reason why we can shed down some of the weight which otherwise the chassis will have to bear. From this point of view, the requirement of smart structure was kind of much more promoted for EVs. These structures are smart in the sense of they have real-time response and they are embedded in structures themselves. Say, for example, suspension system. These suspensions are quite different than the normal conventional suspensions, and therefore lighter, there and therefore more, efficient towards managing the road disturbances. There is a very clear case for light weight or weight reduction, and there's a low power consumption. Most of these devices are active in nature, and therefore better controls can exist. And another advantage is because they are embedded into the controls, there is enhanced reliability in the harsh environments. There are a few examples shown on the screen which are basically talking about what type of smart materials can be used. For example, on the front side of the vehicle, you can see active bumpers. Um, on the bonnet, you will see magnetoresistive fluid engine mounts, which are quite light in nature. Then there are shock absorbers, then active polymer airbag deployment systems, then rain activated automated wipers. All these materials are smart in nature and therefore contribute greatly to reducing the weight. On the side, you will see self-healing panels. and which reduces the requirement of you know strengthening it further. At the rear, you will see that active fiber composite tires, which again have a very high potential for cost reduction, weight reduction. So this is a promising technology which is getting penetrated into EVs much deeper than conventional ICs. It's now interesting to turn into government policies, approval standards, and what kind of homologation related requirements are there in the country. This is one slide which I always like to show in my presentation because I was very deeply involved in this study. This study was done by ARA and Terry for the NCR region for identifying the sources of pollution. And the pollution here on the screen, you will see there on the right, there are 4 columns. Pollution PM 2.5, PM 10, PM 2.5, PM 10 again. 2 scenarios by 2025 and by 2030. These are the predictions, and on the left, there are coming out of the measurement studies, total 7 strategies that can be planned, which will result into a reduction in future. So the first 6 are typically related with the ICE engines. The third one, you can see the private EVs up to 20% and cars and 40% of two-wheelers. If we achieve this, we will be able to get PM reduction of only 5%. Then the 7th one is a public transportation, 20 to 25% if we run on electrification, we will get reduction only by 1%. Isn't that surprising? That's surprising primarily because we are still going to have the old vehicles running. The fleet will still contain old vehicles which are polluting, etc. And also, one has to be mindful that electric vehicles also run on road, and therefore the road dust gets generated, irrespective of whether the pollution is coming from the tailpipe or otherwise. PM pollution is primarily also because of the suspension of the road dust. So electric vehicles are not going to be causing miracles. That I think we as designers should know, and therefore work on our strategies. Electric vehicles will still contain tires which will still get eroded, which will still generate particulate matters, and so on and so forth. I would like to draw your attention to this National Electric Mobility Mission Plan. This was released in the year 2013. The text is not important. The highlighted words I would just highlight. The country is required to develop reliable, affordable, and efficient EVs. Also, there's expected to be a government and industry collaboration. The third aspect was it was anticipated that by the year 2020, the total xEV sale of 6.7 million units was envisaged in the year 2030. And national fuel security was also the focus. Now, why I want to highlight this here is this got to be the vision in the year 2030. As we stand 2020, it's interesting to take a look at where do we stand. Today we have the registered EVs are only 5 lakhs. They are far below the expected numbers. So what is it that we can do? After this, came a scheme called Fame 1. You all must have heard about it. This was started as a follow-up of the National Electric Mobility Mission Plan, and Fame 1 was introduced in the month of April 2015. And it was initially for 2 years, but then later on continued, and it continued until March 2019, last year. This was primarily under the framework of creating demand. Demand incentive disbursement mechanism was envisaged under this. And incentive amount has been determined for each category. And as I mentioned to you earlier, two-wheelers, three-wheelers, and all other sectors have their own peculiarities. And therefore, demand was decided and the incentive was fixed on each category. It also had a provision of encouraging mild hybrid or strong hybrid, plug-in hybrids, or pure electric technologies and battery specifications. Now, in one of my previous slides, I also talked about these technology options resulting into some kind of benefits, CO2 benefits. Therefore, the scheme at that time, in the wisdom of the country, talked about these options as possible incentivized options. Fame India portal was created, and at that time, how many people came forward? It's very phenomenal. About 30 OEMs had registered their vehicle models, and 137 models of all categories of vehicles, primarily two-wheelers, were there in this category. Total incentive amount was about 359 crores for 2.8 lakhs of vehicles was disbursed. The figures on the on the ministry's website indicates fuel savings, CO2 savings, quite impressive numbers for about 2.8 lakh vehicles. This gave rise to the next scheme, which is FAME 2, which was started in the month of April 2019. Why I am highlighting here is I was a part of drafting of both these schemes, and we have done a lot of national learning into deep dive into technologies. What is it that is lacking? What is it that government should subsidize, etc. So FAME 2 was primarily for creating a support system for about 7,000 electric buses, 5 lakh of electric three-wheelers, 55,000 four-wheeler passenger cars, and 10 lakh two-wheelers. That is the overall outlay of about a few hundreds of crores that is available for this electrification. It's interesting also to see that this scheme doesn't talk about hybrids. There is no specific incentive for hybrids. It's talking about complete electrification. And that's the reason why many of the hybrid related development that was happening in engineering colleges, in universities, as well as in research institutes, has taken a back burner. We are moving towards complete electrification, moving again further to hybridization, to hydrogen power generation, and so on. In the year and a half of this scheme now, the outcome so far is 36,380 vehicles have been sold, and resulting into fuel saving of about 1.1 crore liters and equivalent CO2 saving. This scheme is primarily intended at giving the discount to the users through a very transparent government sector. There's a platform which is created on which access is given to the government agencies, dealers, test agencies, OEMs, and there's a core IT team managing it, and the beneficiary gets an incentive through this scheme. Um, and a comprehensive action plan was therefore decided to develop vehicles with keeping their crash and other compatibility in mind. Uh, we also had situations where huge disturbance was there for the technology that was taken for granted. So, in the environment that is shown in the picture, electric vehicles were found to be, very, very highly susceptible. Another challenge was electromagnetic compatibility of these vehicles. And the third biggest challenge was primarily national building code was not yet adopted, and this created a lot of disturbance on getting the resources ready before the vehicles can be pushed to the market. That is not going to be sufficient. Vehicle manufacturer and the dealer, and through that, the consumer gets a direct incentive through FAME subsidy. However, there are several other initiatives. Every state has now come up with their own EV policy. Maharashtra has got, Karnataka has, Delhi has got EV policy, UP has, and several other states are coming up. What they are planning to do is encourage electrification to a large extent in their own states, their own peculiar requirements, and they are extending schemes such as exemption from registration. Delhi has this recently introduced exemption from road tax, FAME subsidy, obviously, and low interest loans are being made available, and also there is a direct tax incentive for the manufacturers. So all that put together is creating, in my view and my experience also, a large interest in making the vehicles in the country. Unless we start making them in a large scale here, we don't get a benefit to the end user. Uh, we also have to simultaneously tighten the regulations in such a way that the consumer is getting a safer and a high performing product. So it's for this reason that I would like to talk here now about the what kind of regulations do exist for electric vehicles. They are no different than other conventional vehicles, but then it's important to see how um, the progress has taken place. Um, the Indian homologation requirements. Homologation stands for it basically means is compliance to the national requirements. So uh, the current requirements as defined under Central Motor Vehicle Rule has approval requirements for complete electric vehicles. There are specific standards for hybrid electric vehicles as well. It also permits conversion of existing fleet into electric vehicles by retrofitment kits. So there are standards related to approval of such kits. And then there are two specific standards related to electric two-wheelers, which are less than a particular, performance range, 25 kmph and say 250 watts and so on. So these are, in summary, the requirements on the screen. You will see that there are a few standards mentioned there. These standards are specific to certain areas. I am not aware whether you will be going through all these details in one of your sessions, but it will be interesting to see that these standards got developed in a span of say 7 to 8 years of time, and they're at a quite matured level now, where a lot of improvement has happened, and the consumer can be assured of better and a safer product. So these standards were, drawn up looking at the India specific needs, as well as uh, it came to say, I'll take the example of battery safety. This is derived from something called US ABC or ISO related standards were taken as a base. Uh, Also, keeping in view the flooding conditions that India might have, also high temperature exposure that Indian vehicles usually have, or heavy duty cycle operations that the vehicle undergoes, and things like that. So, keeping India's specifications in mind, these standards are drafted. They are very well in place. They are available on the website of Ministry as well as on ARIA website. And those who are interested can download these standards from these, you know, websites. Um, what makes electric vehicles different than conventional vehicles when it comes to testing and approval? Brakes are brakes, irrespective of what goes into the powertrain. However, the traction battery, acceleration control systems, and several other safety requirements need to be assessed during the brake testing. That is specifically done, especially because the powertrain has undergone change. So what is seen on the brake of a wheel is coming through the transmission system as well. So therefore, to that effect, the standards are amended, changed, and assessed. On the electronic side, because of heavy content of electrification, heavy switching of currents, there is a large scale EMI generated as well as susceptibility of the vehicle itself. So there is a complete transformation of EMI EMC requirements at the vehicle level. The third is performance emission, of course, because complete EV doesn't have any emissions. But if there is a hybrid vehicle, obviously emission is measured and compared with the original vehicle. Another important consideration is the range. That is of major concern to the consumer, and that's where it actually is measured and certified. 30-minute power and gradability are some such examples of the performance related tests. Um, on the noise, NVH stands for noise, vibration, and harshness. Um, the vehicle is silent, as I mentioned to you. Therefore, in the pass-by noise test, there is a requirement of certain minimum level of noise as well. So that's where actually the synthesized noise is required to be created. And then, of course, there is a horn which is available on the vehicle, and there's a separate standard. So these are some of the examples in which the EVs are evaluated slightly differently than the conventional vehicles. Here are certain specific examples of component related tests. Say, for example, construction and functional safety of the batteries themselves. So it contains mounting, ventilation, creepage, distance, insulation resistance, etc. All those are listed here. The table, can be made available to you if required, and these standards can be downloaded and can be studied. The point is basically all these components which need to be tested and certified um, have to withstand a large duty cycle variability. And that's what makes these standards quite rugged for Indian use. On the screen now, you will see on the top a typical homologation related requirement or a conventional two-wheeler. So when a new vehicle model is brought into the test agency, these are the types of tests which are carried out. On the bottom, you will see the same type of test protocol for a complete EV. The only difference is on the extreme right column, where instead of emission test, there are EV specific tests which are performed. So many times, many people ask me question: why is EV testing and approval so expensive? It's not expensive. If the comparison is with IC engine vehicles, it's just fat bar. It's just that in manufacturing of EV space, there are lots of startups are coming up, and they find uh, this cost of quality assurance or a performance approval, etc., to be beyond their planning stage. They have not considered. Therefore, they find it extremely difficult. Why I am highlighting this to you is they have been cases where many of the research colleges have come to also meet me in my capacity as director area and had requested, ma'am, we have made this vehicle. How much will it cost to test this in the laboratory? So that's the background with which I'm explaining this here. And by no means I would like to justify any cost increase, etc. But one has to be mindful that when we are creating a product for a consumer, we need certain specifications to be approved by the independent agency. Um, I would then like to switch over to challenges and overall readiness of where do we stand today in the Indian ecosystem altogether. We have a large number of challenges ahead of us. Each one by one, it will be difficult to address, but overall, I can discuss it here. Um, I think on the screen you will see a few factors. There could be many more, and maybe I am open for any discussion here, or maybe at the end of the presentation. There's a seamless vehicle to grid connectivity is a big issue. Today, you will see that there are different. Suppose there is a electric vehicle that you purchase, and you would like to know where are the charging stations available, what are their availability. If I go right now, do I get a slot for charging? Things like that. There is a need for standardizing this. There's a need for designing a protocol for vehicle to grid connectivity and also making it available as a common platform. Uh, to large extent, it is available to say buses. In the buses, they have used it extensively, but for personalized use, this data is largely missing. Availability of high quality products, it's a question right now. Any new technology comes with a challenge also. We often let that settle in the market and then we purchase it. So all these vehicles are not yet matured to that extent where we can rely on their quality. User interface and data management uh, is a big challenge. It is said that electrification will remove all the requirements for powertrain maintenance, etc. I think that's a myth. Any machine that you work on will have its own um, problems of managing the data. Developing critical mass for sustaining it. It's as I mentioned earlier, the critical mass for batteries themselves is not yet reached. Therefore, we can't see the battery manufacturing in the country. Likewise, for electric vehicles, complete vehicle development is not yet happening in the country. Only a handful. Out of that, also, there's about 50 to 60% import is happening. Repair and maintenance network. This is a complete new skill requirement that is being posed at the national level. There are hardly any mechanics who would be knowing how to repair, um, the powertrain that is going on the EVs. Consumer awareness and acceptability. So these are the some of the factors that we have to still work upon. On the technology side, Um, on the FAME, when we drafted, and along with it, I was also involved in making the standards for charging stations. There's a chicken and egg situation. We can be more specific to a product standard. We can say that we want interoperability, and therefore all the vehicles must contain this particular charging receptacle or charging protocol, etc. In doing so, we would be stopping in some of the international products that otherwise would find an entry into the market. So, therefore, this chicken and egg situation has arisen looking at what Chinese connectors are, what kind of European connectors are there, what ISO connectors are there. So, this is one area where we always struggled in making charging standards and interoperability of the connectors and their protocols. Um, to certain extent, those products which are designed in the country, we can kind of push the national requirement. However, in the interest of other products of other countries entering into the market, usually you will see some of these vehicles, such as Nissan Leaf, for example. It comes with its own charging system. The Hyundai Kona comes with its own charging system, and also are the Japanese other products coming in. So there's a lot of uncertainty about how to standardize, how to kind of arrive at India-specific requirements. For the buses, for the other sectors, three-wheelers, there's a large-scale possibility of standardizing that has been done. This is for electric motors. That I was also engaged into an advisory group on what type of material will be required for developing electric motors in the country. There's a large import which is happening currently, and that's therefore a major focus at the import substitute. That's the biggest one of the candidates is electric motors. Fast integration of power electronics, vehicle controls, and data management. In fact, I would look at it as a India's strength. We always had very good power electronic control systems development, not in automotive but in other sectors. So it's very, very prudent to draw up strength from power electronic sector. Vehicle controls we always were very good at, and data management obviously there lies the India's strength. So in my view, vehicle designers or EV design sector, if we focus on the third bullet point, I think we would not be disappointing our own, targets. We can do a wonderful job if we focus on the third bullet point. And the fourth one is obviously of great importance and great interest to me as also is options for alternate battery chemistry. I have a few slides on the battery chemistry also, and I have seen that your course also includes a detailed discussion on various applications of various chemistries. Um, Another challenge which we have seen is in disbursement of incentive. The government, in its own wisdom, had defined that there should be a large-scale localization so that there is a Atmanirbhar Bharat targets are met, and therefore localization of EV components, especially BLDC motors and controllers, at China price. That's another big challenge. Manufacturability of these products in the country, um, permanent magnet manufacturing at the imported price point is another challenge. Um, all that put together, there is a complete supply chain, and encouraging auto component manufacturers to supply auto parts at a reasonable rate, and that is what simultaneously must go on. Product development, testing, validation, field trials um, is a long drawn process. In fact, if we look at how the vehicles got developed, um, government had announced certain plan for electrification, and certain figures were pushed to the manufacturers, and certain targets were defined, and they were not defined on the CO2 emission level, but they were defined in electrification numbers themselves. Now, manufacturers work slightly differently. They have invested heavily by this time in BS6 development. Therefore, if you look at every manufacturer comes up with only a handful of vehicle models. That's because they have to sustain their own investments, and therefore their product development needs to be also supplemented with a large scale electrification concept and an assurance for the country. Then fleet operator requirements, OEMs may be encouraged to work through fleet operators, and that's what is currently happening also. Uh, the fleet operators are tying up for the urban mobility for large fleet electrified platforms. On the powertrain side, appropriate component sizing is also a big issue. As I mentioned earlier, range is just a mental anxiety. Range of the vehicle, you are going to be getting an opportunity to charge again. But the mind works differently. If I were to buy a vehicle and I say in one charge, I must be able to run the vehicle from Pune to Goa and I don't have to stop in between, then that becomes too much. Uh, then no vehicle designer will be able to offer the right solution. So this is one thing which is the hindrance. One has to be mindful of the real life conditions also, and then overloading and designing for Indian abuse conditions. This is more so for three wheelers and the goods transportation vehicles. That is a major concern for technology. I mentioned earlier that battery can be swapped as a technical option, and the concept has been proven satisfactorily, especially for the buses and three wheelers. The concept is pay by the use, and rather than paying upfront for the acquisition cost of the battery is taken on loan or it's taken on lease, and it therefore reduces the upfront vehicle cost, acquisition cost, because the battery cost is separated from the vehicle and it is amortized over the useful life of the battery. And leasing arrangement is therefore entered, and by which the user is able to pay by use. Another technical advantage swapping can give is charging is done at the docking station. So you don't have to keep the vehicle in, say, rainy environment or a sunny environment, because if you charge your vehicle battery at that raised temperature, you will find it difficult to sustain. Therefore, taking out the batteries and docking it in the docking station is better technical option. Whether we can do it for all types of vehicles, that's a question. But we can definitely try it out for smaller vehicles um, such as three wheelers, where the batteries are relatively smaller and accessible, or even two wheelers. And buses need very special tools and techniques to remove used batteries. It also, therefore, as an additional advantage, it gives a reduced range anxiety. it removes the concern of battery running out of charge. As we are getting closer to running out, we can always go to the docking station, get the alternate charged battery in place, and then get going. So these are the good advantages of a swappable battery option. This has been tried out in Delhi. It is working fine, and I had headed that committee which recommended these options, and successfully been tried out, and therefore a good option for the country. Um, if we now go back to the lithium ion, what is the future? There are debates going on that our dependency from import of batteries will shift to import of lithium, because lithium is also not available in the country. Um, there are counter arguments available, and it's a technical fact that lithium ion will dominate EVs for at least coming 5 to 10 years before we get an option for the same. Um, in this lithium ion also, there are various other options available, various other chemistries which can be tried out, and therefore migrating to more efficient lithium ion is what is going to happen in next 5 to 10 years. Um, this is the graph which indicates the manufacturing base of battery by region. It is, if we look at 2020 pie chart, it shows about 58 to 60% of the manufacturing of batteries is happening in China. Then North America is 10%, Europe is 15%, and rest of the world, which includes India, is 17%. So this dominance is going to continue for coming years as well. And therefore, unless India is engaged into large scale or gigafactory related to battery manufacturing, I think there has been taken some steps towards that, but we would be really speaking minuscule in manufacturability of batteries. So this is still going to be a major drawback for us to make an impact on EV development. So there are many flavors and chemistries of lithium ion, as I mentioned earlier. So different cathode combinations, different cell energy density, and you know, these are the figures which we learned from our expert, Dr. Prabhakar Patil, who works on batteries to a very great extent. He has been spending a large part of his career in battery development. So we learned these from him, and we are at ARA also decided to continue working on lithium ion and get the best benefit out of it. Other materials of interest are cobalt, nickel, and lithium. These are the substances of interest, and they have promising, you know, outputs at the laboratory level as well as pre-production level. However, large-scale manufacturing still will be focused on lithium ion. India has a large EV ecosystem action plan in place, and I think most of these points I have already discussed earlier. But one-time cost of the battery is the one which will govern it, and there are several other aspects which we are learning from the global markets. I mentioned here about Volkswagen setting up EV production through joint ventures. That is what is going to make a difference. Many of the manufacturers are coming up with common platforms to reduce the manufacturability targets as well as getting a competitive advantage. They are commonalizing on the platforms, which is a good thing. Never done so far. Uh, all these years, everybody believes in making their own vehicles. Everybody designs their own specific vehicles. It's time that A lot of communalization should happen. Consortium approach works better. It has worked well earlier also. So this is where the government push is required. There could be some ventures which are happening on their own, but there could be some which are to be pushed by government efforts. So all that is the dynamics which is likely to happen in future. And that was my last slide. And with that,